That's not chess. Feels like we come full circle every time we see this, doesn't it? Again and again. Groundhog Day without the groundhog. Groundhog Day without the groundhog. But we're getting tighter and tighter. Did they go to the moon? Of course they didn't go to the moon in 1969 or 79 or 89. Because if you can't prove the first one, it's like the first pyramid stone, isn't it? Now, this isn't about flags waving and the eagle's shadow and no stars in the sky when they were taking pics. Armstrong's footprint being the wrong shoe in the wrong place, mirrors on the moon, which there aren't. The list goes on and on. This angle is about these dates and the people that are involved with space travel. Right? Now, Copernicus, forget him. Galileo, 1546 born. Tycho Brahe, 1546, Johannes Kepler, 1571. We go all the way down to Isaac Newton, 1643, Olaus Römer, 1644. And their discoveries, we've got a bit of possum dog action going on over there. 1610, 1600s. Look, couple going into the 1700s. This was when they discovered their thing, their niche, the planetary laws of motion, or the 3 laws of motion, the refraction, right? The blues. Now, first of all, why were so many people involved in all of this space travel stuff that aided Apollo 300 years before electricity, in some cases, before the motor, before the engine, before the battery, before anything? Why on earth were these people doing all of this? And in Europe, now let's get something straight here. Poland, no Copernicus, Italy, Denmark, Germany, Netherlands, France. These places, there was no cars, there was no nothing. These places, it was horse and carriages. It would have taken months in some of these places, like to go from, I don't know, Italy to Denmark. I mean, that's over 1,000 kilometers. There was no choo-choo trains or anything. There was nothing, right? Why are all these people so concerned about all of these things? Galileo, Jupiter's moon, Saturn's rings, planetary motion, found out the elliptical orbits, Kepler. It just goes on and on. Edmund Marriott, blind spot, visual fields, Christian Huygens, the centrifugal force, Saturn's rings, the wave theory of light. In 1674, Isaac Newton, his laws, 1687, Olaus Römer, speed of light, in 1676. Look, what is this? What is this influx of space-oriented scientists that come out of nowhere 300 years before they were needed? Why? Why did that happen? Let's look at the top bit. October the 4th, 1957, the Russians launched Sputnik. The space race began. 1957, 12 years before Apollo went up. All right? 12 years before Apollo went up. That is why all of these people did what they did. They came out of nowhere. 1609, Johannes Kepler, the laws of planetary motion. Worked out some of the planets have elliptical orbits. How in 1609 do you work out that planets have got elliptical orbits. And why? Why are you doing this in 1609? Hundreds of years before power, hundreds of years before battery, hundreds of years before even thinking of flying, hundreds of years before anything. Why? Is he working out the laws of planetary motion before anything else? Is that logical? No, it really is not logical. 1687, Newton's laws. His third, every action has an equal and opposite reaction. Now, what was Newton doing? Working out laws in 1687. One of those laws being every action has an equal and opposite reaction. Hundreds of years before the first flight, before there were engines, before cars, before motorbikes, before bikes even probably. Why on earth was he working out every action has an equal and opposite reaction? And even if he was, why on earth would he be referring to space and travel in space in 1687 when there wasn't even an engine? These are the questions. This is the bizarre bit about it all. 1772, Lagrange, the three-body solution. The three-body solution is the sun, moon. I'm going to do the three-body solution up here real quick, because that's where the James Webb telescope is right now. Right? So what we've got the sun. We've got Earth. That's miles away, but right, not to scale. And the moon. I think the moon. We're switching between the two, and there's a line that goes through them. And then I think, I can't remember exactly how it goes. Like one's there, one Lagrange point's there, one Lagrange point is there, and that's where the James Webb is. And how does this go now? Something like that. And then there's another spot here. And then, I don't know, the other two, somewhere there or something. So these points are points in space where, because of the sun's gravity and Earth's gravity, there's a dead spot. And you could just hover with minimum effort. So that was something that has come about quite recently, but it was very handy for the James Webb Space Telescope. Oh, the possums are out tonight. This Christian Huygens, 1674, the wave of light theory. The different points of a wavefront or wave crest of light set up an infinitely numerous series of secondary waves. These secondary waves reinforce each other after a time and produce a new wavefront. Other secondary waves arise, and these result ultimately in still another wavefront. Thus, light is propagated. Now, how on earth Christian Huygens worked this out in 1674, 200 years before a light bulb, before electricity? And why? Why was he working this out? Why? It does not make any sense. Why were all of these people working all of these things out up to 300 years before they were needed? The speed of light. It hasn't been worked out. All of these people say, yes it has, yes it has. No it hasn't. I've yet to see a calculation that makes sense for the speed of light. It has not been worked out, and it definitely hasn't been worked out for the sun. It's impossible, all right? 1676, Olaus Roma, speed of light using the telescope Jupiter and Io, over a decade of taking measurements, okay? This thing flat on its face as soon as the telescope comes out, okay? It was said that over a decade, or 9 years, 10 years, when we were closest and furthest from Jupiter, here's the sun, here's us, here's Jupiter, miles away, right? So when that's the sun, that's our orbit this side of it, and this would be our orbit the other side of it. So he was taking measurements of the moon Io, it's one of Jupiter's moons, as he was doing the rounds, right? He took it from here, when we were furthest away from Jupiter, so Jupiter's orbiting that way, we're orbiting that way, when there was just enough of an angle to see Io because of the sun, he was taking readings, right? Oh yeah, there's Io, looking good. And then he took readings, boom, and then boom. Closest to Jupiter, furthest to Jupiter, over 7, 8, 9 years or something. But he was always looking with a telescope. So what delay would there be? He's looking with a telescope here, and he's looking at that moon coming out from behind Jupiter, and then all the way back over 7, 8, 9, 10 years, always with a telescope. What delay, what light delay would there be? None whatsoever. But there's a distance of 150 million kilometers between Earth and the sun that way, and 150 million kilometers between Earth and the sun that way. So from here to here, that's 300 million kilometers difference. And they reckon that the readings that he took when we were furthest away from Jupiter, that there was a 20-something minute delay in Io coming out, right? And they've said that that was because of the distance from Jupiter and Io and the delay in the light getting back to him. Rubbish. First of all, he was taking it with a telescope. Second of all, there is no light delay. There is no light delay. It's common sense. It's common sense, right? Then we've got, so that was in 1676. Why would somebody be out there with a telescope over 10 years looking up at Jupiter trying to, I can't believe we're talking about this again. 1728, James Bradley. The method was aberration. Aberration is when you look up at the star, right? And then there is the likely place it might be. What was it called? I can't remember. There's a place where it might be because of that light delay again. See, they're trying to introduce this light delay thing. This 8 minutes, 20 seconds for the sun's light to reach Earth. There is no delay. Why all these little things with little delays in? Little push, delay. So aberration, he's looking up, he sees a star, and because of the light delay, something to do with aberration, there's something to do with the speed that planet Earth was traveling at. He was able to work out the speed of light. You will not hear anything so stupid until we get to this one. Fizeau, 1850, Fizeau, with a beam of light that travelled 16 kilometres. A beam of light that travelled 16 kilometres, right? So he's got a mirror, right? And this beam of light shoots 8 kilometers, right? It hits another mirror, and bounces back, and it bounces back. It lands on a toothed wheel, right, through a hole in a toothed wheel. It's getting spun. What kind of beam of light in 1850 before electricity? This is the thing. This is key. There were no beams of light that could travel even 2 kilometers, even a kilometer, because all they had was sunlight and naked flames, like lamps, oil lamps, paraffin lanterns. There was nothing else. So how on earth do you get a beam of light to travel 16 kilometers in 1850 before even the bulb was out? Right there, that puts that to sleep. Boom, boom. It puts that to sleep. Boom, boom, because of the telescope. And this one, you have to read up on aberration and go outside and try it. You can't just sit there. This is what's happening. Everybody thinks everything is so easy. It's not, right? You have to put yourself in the first person to do these things. Nobody's willing to do it, and everybody's like, yeah, no, you're just a conspiracy theorist. You lot just need to wake up. God, it's right in front of everybody. Apollo, 1969, right? Space race started in 1957. Newton, 282 years. His laws, right? 282 years before Apollo took off. What on earth is Newton doing? Every action has an equal and opposite reaction. 282 years before Apollo took off? Why? It's illogical. No motor, no engines, no nothing. Kepler, 360 years before Apollo took off. Lagrange, the three-body solution. James Webb's up there now. 248 years before he was needed. Why? Why were all of these people doing this stuff? Christian Huygens, 206 years before electricity, he worked with different points of a wavefront or wave crest of light, set up an infinitely numerous series of secondary waves. These secondary waves reinforce each other after a time and produce a new wavefront. Other secondary waves arise, and these result ultimately in still another wavefront. Thus, light is propagated. 204 years before electricity, 1674. Why? James Bradley, he looked up at a star. A bit of aberration going on. I had a lot of trouble finding this guy in some of the books. In the earlier books, he wasn't there. 150 years before electricity, Fizeau, the magic beam of light, 16 kilometers. A light beam that traveled 16 kilometers. That in itself is impossible in 1850 when there were no beams of light available. But nobody really thinks about these. Well, it's not that they really think about it, it's what can you do about them, right? And the biggest tell of all is Apollo's descent from 112 kilometers when it's separated from the command capsule, the Eagle. There is no explanation anywhere for the descent in 1969 of the Eagle after it's separated from the command capsule at an altitude of 112 kilometers. fact, this is exactly what I'm talking about. Hang on. Where's my glasses? Right. And those of you that, yeah, I do get it quite often. Hey, you conspiracy theories getting your crap off of YouTube? No, I've done this once, I've shown this once before. I don't get my crap off of YouTube. You don't go to YouTube if you want the truth, do you? Books, it's old books. That's where you get the truth. Right. Now, let's do them. Right. This is exactly what I'm talking about when I talk about an explanation for how 1970, 1941, 1965, one giant leap for mankind. All right, so this is the first of it, right? This is when, where, why, and how it happened. History's most dramatic events and how they changed the world. Right? The first page. What was that? See anything? Right. First page. Oh, can't read that. Yep. As the astronauts Neil Armstrong and Buzz Aldrin neared the moon on the afternoon of July 20th, 1969, they came close to disaster. As their ungainly insect-like lunar module, codenamed the Eagle, dropped from its orbit around the moon, it was essential to find a smooth place on which to land. But at 700 feet from the moon's surface, the astronauts found themselves too low to pick out the landmark craters they'd studied from Apollo 10 photographs. Are you kidding me? Read that again. Near the moon on the afternoon of July the 20th, they came close to disaster as their ungainly insect-like lunar module, codenamed the Eagle, dropped from its orbit around the moon. It was and then it just goes on to Armstrong changed to manual command and slowed the module's descent. He guided it down to 300 feet, 90 meters, then 200 feet, 60 meters. The Eagle skimmed forward beyond the intended smooth landing site. It just goes on, right? On a dusty pockmarked plain known as the Sierra, some 4 miles further on, Armstrong described what he saw below, an alarming spectacle of boulders the size of Volkswagens. It would have been suicidal to land there. Armstrong accelerated safely past the boulders as Mission Control in Houston waited in an agony of apprehension. There was fuel in the descent tank for only 60 seconds. In this time, Armstrong must find a landing site, or Aldrin would be forced to switch to the ascent tank and abort the mission. Still, Eagle descended to 12 meters, 30 feet, 9 meters. If it ran out of fuel at this altitude, it would crash into the surface before the ascent engine could lift it back into orbit. We were in the so-called dead man zone, Aldrin said later, and we couldn't remain there long. Just as the descent engine sucked up the last of its fuel supply, Armstrong put the module down on the moon. Oh, God. Still, Aldrin sat ready to switch to the ascent engine and abort in case the moon's powdery surface would not support the weight of the module, where it proved to be damaged. But all was well, and Mission Control heard Armstrong's voice through the crackle of static. Houston, Tranquility Base here, the Eagle has landed. Now, all of that was the explanation for the Eagle landing. But how is that even possible? Right? This is the bit. How is that even possible? command capsule and the Eagle's separated, okay? I don't know, I didn't think it's got claws and all sorts of stuff going on, right? It's the Eagle. We are at 367,000 feet, right? 112 kilometers altitude, right? We're traveling at 5,800 kilometers per hour. The command capsule with Collins is traveling 5,800 kilometers an hour. So is the Eagle, because it's just separated. They're going to go down, right? We're at an altitude of 367,000 feet. A passenger plane, right? A passenger plane, its cruising altitude, its average cruising altitude is 35,000 feet, okay? 35,000 feet. The Eagle is at 367,000 feet. That's 10 times, over 10 times the altitude of a normal cruising. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it would be 10 and a bit, 10 and change, right? 350. How on earth, in a vacuum, now this is the bit that everybody's missing, because everybody's switched off from the vacuum, how hard it is, how difficult it is. In a vacuum, there's no molecules. There are no particles. There are no atoms. There is no matter. There is no resistance of any kind. Now, excuse me, but what kind of thrust comes out of the bottom of the Eagle, right, into the vacuum, that's going to slow the Eagle down from 5,800 kilometers an hour, and that is 7 times the speed of passenger planes, right? So we've got 10 times the altitude, 7 times the speed, high, right? What kind of thrust allows that in 1969, with next to no notice whatsoever, to land on the moon? And why is it that we, every single timeline, this part of the journey and 5,800 kilometers an hour is 4.6 times the speed of sound, which was a new one that got added. That's how fast the Eagle was travelling. Why is all of this left out? And why do we always go, they separated, and now we're about 600 meters from the surface? If that is not a tell enough, the whole of this is missing everywhere. And it's missing for Apollo 11, 12, we won't call 13, they had to throw a numpty in, because otherwise it will look too perfect. 14, 15, 16, I think 17. 6 launches, 6 successful launches. 2 men from each mission touched the moon, landed on the moon. Some of them in buggies. There is never an explanation for this bit. And this bit is the ride. This is the... Where is it? Smoking gun, please. Come on. It's ridiculous, is what it is. Absolutely ridiculous. So those are the angles why the Apollo 11 did not touch down. First of all of these people, what are they doing 300 years before there was any flying even thought of, right? There was no engines, there was no wings, there were just no nothing, right? But why are all of these people working out all of this stuff all over Europe? And why is it that straight after the space race, America got hold of all of the stuff? How did that happen? Well, it's because of him we can do this, and because of him we can do this, and it's because of him we can do this, and it's because of him we can do this, and it's because of him we can do this, and it's because of them that we can do this, and it's because of him we can do this. That is what won the space race. I would love to see how many of these people exist in history books, like in science books, in, I don't know, encyclopedias, pre-1950, 1940. See how many of these people exist. Because I bet you there won't be many of them. They've been planted so that the space race could be won. And that is why Apollo 11 never landed. And if Apollo 11 didn't go, if there is no evidence for the first one, and hey, don't get me wrong, if that evidence is somewhere, I'd love to have it. Loads of people would love to know how you descend 112 kilometers, 367,000 feet, 10 times the altitude of your average passenger jet cruising down here at 35. At a speed of 5,800, 7.2 times the speed of a passenger jet up there in a vacuum. That is high. How did it get down? How did that thrust work into a total vacuum? That used to be a big deal back in my day. Why is it all of a sudden, it's just like not a big deal? This is why it never happened. People avoid these questions, don't they? Coming back to the speed of light and why the sun's light is absolute, and there is no doubt about it. It's another absurdity where they drop the ball with the numbers. And the pyramids, it's a slam dunk. The Egyptians had absolutely nothing to do with them.